Hi everyone, welcome to Cloud Computing series. In this video, we'll be learning about clusters of cooperative computers. A computing cluster is made up of interconnected standalone computers. See, a cluster is a group of separate computers that are connected together through a network. Even though each computer can work alone, they are connected to work as a team. Then these computers work together cooperatively as a one integrated system. That is, all the computers in a cluster share tasks and help each other, acting like a single powerful computer. Then clusters have been very effective in handling heavy workloads. Means clusters can do difficult or big jobs faster than one computer because they divide the work among all connected machines. They are also great at working with the large data sets. Means when there is a lot of data to process, clusters can handle it easily by using multiple computers at once. See, over the years, clusters have proven to be very fast, reliable and powerful, especially in research and industries where speed matters. Then moving to the next. See, this is a cluster architecture. Here a blue oval shows a cluster of servers like S0, S1, S2 and so on. These are individual computers and these servers are all connected using a fast internal network like storage area network, local area network or a network attached storage and technologies like Ethernet, Mirnet or a InfiniBand. See, the servers share resources like input-output devices used for input-output operations and disk arrays for shared storage. And this gateway connects this entire cluster to the internet. Yes. See, in a simple way, it is like a team of computers working together, sharing storage and devices, all connected with a super fast internal network. This whole team appears to the outside world as a one powerful computer. Yes. Server cluster is built using a low latency and high bandwidth network. Means clusters are connected with the fast networks that can quickly send large amounts of data between computers with a minimal delay. The interconnection network could be storage area network like a Mirnet, which is very fast and used in high performance settings. Then local area network like Ethernet, which is commonly used in offices and homes. Big clusters connect many machines using layers of switches to manage traffic. They use faster technologies like gigabit Ethernet, Mirnet or InfiniBand. These ensures quick and smooth communication between machines. See, we can make a cluster bigger by connecting more machines using different types of networks like a storage area network for storage heavy tasks, then local area network for local connections, then wide area network for connecting across long distances. See, a VPN gateway connects the cluster to the internet and its IP address identifies the cluster. Means to connect the cluster to the internet securely, a virtual private network gateway is used. This gateway has a unique IP address that helps identify the whole cluster online. Each node in the cluster usually runs its own operating system, making the cluster loosely coupled. Means every computer in the cluster typically has its own operating system. Means the computers are not tightly connected or controlled by one central system. They work independently but cooperative when needed. Since each computer has its own operating system, the cluster does not behave like a one big computer with a single interface. Instead, it has many system images like different screens for each machine. The next subtopic is single system image. See, Greg Pfister stated that an ideal cluster should merge multiple system images into a single system image. That is, even if a cluster is made up of many computers, it should behave like a one single system. This way, users don't have to worry about which computer is doing what. Everything is managed together. SSI is an illusion created by a software or a hardware that makes a cluster of many nodes look like a one single powerful system to the user. That is, it hides the complexity of a multiple computers. It tricks the user into thinking there is only one computer when actually there are many working together. Yes, this is done using a special software or a tools. For example, like how Google has a many servers but looks like a one website to the users. See why SSI is important? With the SSI, we can use the CPU, memory and input-output devices of all the computers together, yes, as if they are parts of a single machine. Then it improves the usability, management and performance. It becomes easier to use, manage and monitor the cluster. Also, since all resources are pooled together, the overall performance gets better. See, then makes the cluster easier to use and manage like a single big computer. That is, users or a system admins don't have to deal with each node individually. They just work with the cluster like it's one big computer. Then without SSI, a cluster is simply a group of independent computers with a separate system image. That is, each computer has its own operating system and behaves independently. Yes, the cluster won't feel like a single unit. No unified resource management. That is, we can't manage all the computers as a one. We have to handle them one by one, which is time consuming and harder. See, how is SSI achieved? See, a cluster operating system or a middleware, that is a special software layer, helps combine all the nodes into one system image that supports CPU sharing, can run programs using the power of multiple CPUs across a different node. Then memory sharing. Memory from all the nodes is used together, making it feel like a one large memory block. Then input-output resource sharing. Devices like a storage or a network can be shared by all nodes as if they belong to one system. See, the next topic is hardware, software and middleware support. The clusters that explore a massive parallelism are called massively parallel processors. That is, massively parallel processor systems use many processors to work on different parts of tasks at the same time. This is very helpful in speeding up complex computations. See, the top performing supercomputers in the world use this technique because it's the fastest and most efficient for a large tasks. Then building blocks of a cluster. See, these can be a normal computers, a servers or a powerful workstations. They are the basic working units. Then network interface cards in each node. See, every node has a NIC to connect and communicate with the other nodes. Then communication softwares such as parallel virtual machine, then message passing interface. These help nodes talk to each other and share data for a parallel processing. See, most clusters run on a Linux, which is a flexible and efficient. Nodes are connected via high bandwidth networks like gigabit Ethernet, MirrorNet, and InfiniBand. These ensures fast data exchange between nodes. Moving to the next, see middleware support. Middleware is nothing but a software that connects different nodes and systems together. It supports single system image that makes the whole cluster behave like a one big system. Then high availability that keeps the system running continuously even if some parts fail. Then clusters support sequential and parallel applications. Sequential applications run on a single node. Then parallel applications split across multiple nodes using a distributed memory. See, for a parallel environment, distributed memory is used. That is, each node has its own memory. Even though each node has a separate memory, distributed shared memory creates an illusion that all memory is shared and accessible, just like a one big computer's memory. Then some of the challenges in a clusters. See, making everything act like a one system is a complex and a costly. So most clusters are loosely connected, where each node still works mostly on its own. Then virtualization. Virtualization allows creating virtual computers instead of physical ones. So we can quickly create a cluster using a software without setting up real hardware. That is very flexible and efficient for cloud computing. The next is major cluster design issues. Cluster-wide operating system. Unfortunately, a cluster-wide operating system for a complete resource sharing is not available yet. This means there is no single operating system that can manage all nodes in a cluster as a one unified system. See, right now there is no single operating system that can fully manage all the nodes in a cluster like it's one big computer. Each node usually runs its own operating system, so managing the cluster as a one unit is still a challenge. Then role of a middleware. See, middleware or operating system extensions were developed at the user space to achieve SSI at a selected functional levels. That is, there is no cluster-wide operating system. We use a middleware, that is special software to fill the gap. Middleware helps make many nodes feel like a one system, also known as a single system image. It's like adding a layer on top of the operating system to make everything work together. The next is importance of performance. See, the software environments and applications must rely on the middleware to achieve high performance. Means to get a good speed and efficiency, especially in a big or a complex tasks, the middleware is a must. It helps in managing resources, communicating between the nodes, and running apps smoothly in a distributed setup. So thanks for watching. If you found this video helpful, don't forget to like, share and subscribe for more insights on cloud computing, and also check out our playlist for more in-depth topics.